Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. To differentiate 1,1-dichlorothane, CH3CHCl2 and 1,2-dichlorothane, ClCH to CH2Cl, we need a reagent that reacts with one but not the other, producing a distinguishable product. Moving on to the next step. Consider what happens when each compound is treated with aqueous KOH, hydrolysis. 1,1-dichlorothane, CH3CHCl2, undergoes hydrolysis with a KOH. The geminal diol intermediate, CH3CH2 formed is unstable and loses water to give acetaldehyde, CH3CHO, an aldehyde. 1,2-dichlorothane, ClCH to CH2Cl, undergoes hydrolysis with a KOH to give ethylene glycol, HOCH to CH2O, a diol with no carbonyl group. Moving on to the next step. After treatment with a KOH, add 2,4-DNP, 2,4-dinitrophenylhydrazine reagent. Acetaldehyde from 1,1-dichlorothane is an aldehyde carbonyl compound and will give a positive 2,4-DNP test, forming a yellow-orange precipitate, 2,4-dinitrophenylhydrazine. Ethylene glycol from 1,2-dichlorothane has no carbonyl group and will not react with 2,4-DNP, giving no precipitate. And for the final step, if 2,4-DNP is added first before a KOH, neither compound has yet been converted to a carbonyl compound, so no differentiation occurs at that stage. The order matters. NiHSO3 reacts with aldehydes and methyl ketones but cannot directly differentiate these two dichloroethanes without prior hydrolysis. Lucas reagent ZnCl2 conc. HCl differentiates primary, secondary, and tertiary alcohols, not vicinal or geminal dihalides. Therefore, the correct sequence is a KOH first to hydrolyze and generate acetaldehyde from 1,1-dichlorothane, then 2,4-DNP to detect the carbonyl compound, which is option B. Therefore, the correct answer is B. Therefore, the correct answer is option B.